Hello. So I'm Terrell Russell. I'm a chief technologist at the moment for the iRODS Consortium. And I get to say all the words about what we've been working on. Jason stole a little bit of the thunder, but it's okay. It's okay. Part of the way through this talk, I'm going to have three of these characters come up here and talk about what they've been working on. So it won't be just me. So Jason used up exactly 7 of his minutes, so we have more time than we expected, but that's good. Every year. So in the last year, we have had 4 core releases of the iRODS software itself. Everything that was incorporated in the 4.1 series has been forward ported and is already obviously involved in 4.2. But otherwise, that's 60, 70, 140 particular items. Some of those are things that we've added, but the vast majority of those are things that were found by others, found by us, that needed to be improved or fixed, which means that this is becoming quite solid now, and we're pretty pleased with ourselves. The things that people are finding now that don't work are strange and in the dark corners, which is good. I mean, the vast majority of things that we expect to work now behave very well. In addition to the core itself, it turns out that when you go to a plug-in model, a lot of your time gets spent building and maintaining plugins. So I was going to start digging and finding numbers for all of these other things, but that was a lot of work, and so I didn't. So I give you a list instead. So we've released, I guess, 8 different plugins that are kind of standard now alongside the core releases. The way that we currently produce our software, we've still tightly coupled the version numbers because we don't feel like we're quite smart enough yet to decouple them completely and trust in our model, but we're getting there. So every time we release a core, we stamp one out. We also release all the plugins alongside to keep their version numbers consistent. The client landscape that we've started to work on has grown. So some of these were out at this time last year. We've done considerable work on the Python iRODS client itself. The cloud browser was the GUI that we had been building for a few years. And it's probably going to have it's probably its last release any day now. I've been saying that for months as we fix a couple outstanding bugs. The bulk of the work on the GUI from our perspective has moved to Metalinks. It's got a couple drivers in the community, most notably NIEHS. It was originally donated by Dell or Dell EMC, but that's the thing that's probably going to spend the most time and money from our perspective in helping build a GUI for a web. But we want it to be nice and generic, so that's also a challenge because everybody wants it to do something very specific. So we're working on skinning technologies and making sure that it's as lightweight as possible, provides a generic interface, but will allow people to customize it and skin it and add more, depending on whether they're in a particular domain where they want to use their words, because we don't know your words necessarily. Strange words. NFS RODS is something that we have done for the first time this year. We spent a lot of time, I guess, last summer getting a first version, and it presents iRODS as NFS. And so there's a lot of interest in this in different communities. It will afford much easier interfacing into legacy systems, tooling that doesn't need to learn about iRODS. They can just write to a mount point. So that's exciting. And then the automated ingest framework itself is a Python client that allows us to do parallel ingest. It's a much better iReg. We've had iReg for a long time, but it is extremely serial, and that doesn't go well when you have 10 to 20 million files you need to get in quickly. So we've done all this work, and it mostly all works. It's great. To put some names on these things, some of these names are still with us. Most are still with us. Some of these are not in our group, actually, but this is just, again, numbers from the core software, not from all the plugins. These, these are not big numbers, but every one of these commits pretty much closes an issue because we have a pretty robust CI now, so it doesn't go in until it's good. This is a list that I kind of maintain all the time because we run the technology working group every month, and so we give a little update, try to keep a status for all these different irons that are in the fire. We're working towards 4.2.7 and 4.3 kind of simultaneously. Again, you've seen a couple of the things from the last slide. We've worked on our capabilities this year. We've got these 8 that we've been talking about for a couple years now. The story is becoming clearer. We're actually shipping code that solves these problems. Of course, we're maintaining the clients. We've worked on Lustre integration. One of the things that we're interested in is keeping up with computers that go fast and not get in their way. So we've got some work around that. We've been doing some recent work on designing our first pattern around metadata extraction from certain file formats. So we're learning, kind of getting our feet wet with NetCDF. It's very rich, lots of different modalities and how that stuff can exist in the world. So we're trying to make sure that our approach is generic and easy, but also functional. We expect to have some kind of menagerie or zoo where we keep all of our extractors. So if there's something that, a particular file format that's interesting to your science or to your workflows that you think would be helpful for others and kind of raise all the boats, we'd love to have a conversation around that because I don't think it's going to be very complicated once we figure out exactly what one of them looks like, right? At that point, they will all look very similar but do different work for different file formats. We have had a lot of interest in our unreleased Rados plugin. It has been out since, let's see, it was 2000 something, I don't know, a long time ago. We were in, I don't know where we were, it was a long time ago, 4, 5, 6 years now, and it is now running in a variety of test environments, but because of our CI, we haven't been able to incorporate it directly, therefore we will not release it and put a number on it and put our name on it yet. But it does work, and we are working very hard, and you'll hear about it in a few minutes, about our CI that's going to be able to take that on. We've also got work around cashless S3, which is very exciting. The NFS rods and the cashless S3 each have their own talk. So Cory and Justin will be talking about those separately later. I guess they're both tomorrow? Both tomorrow. We've worked around the multi-part transfer and kind of redesigning how we move data around, both in terms of can we pull it out and make it more of a plug-in so that it's not dependent on our code, but we can have different transport technologies, as well as looking at our API itself. Can we simplify it? Can we make it easier for other developers to approach and plug into our stuff? And then obviously the testing infrastructure itself is complicated and interesting enough to have Jaspreet talk about it in a few minutes. So we've had these 8 different capabilities. We've talked about them for about 3 years now, and they are becoming real. We've got 5 now that have code, which is exciting. That means that you don't have to write the code. You just have to turn some knobs, set some configuration, and you theoretically can't hold it wrong. That's the idea. So you can do very complicated, nifty things without having to write your own programs. Auditing was first. That right now in our implementation emits an AMQP set of messages. We could retool it to do some other technology, but the point was we wanted to be able to send messages out in a standardized format and let people plug it into their infrastructure and see what they can find out about it. We haven't really changed it since our initial release, which means nobody's using it, or we nailed it. We're going to go with B. The automated ingest tool was first released last year and has had significant retooling as we learn more. Storage tiering just got rebuilt from the ground up, kind of torn down and rebuilt. And Jason's going to talk about that. We're not talking about that. Ask us about that. It's great. And then indexing and publishing is what Jason's going to talk about tomorrow morning. Provenance is hard. We have some ideas we've drawn on the whiteboard. No code yet. Integrity, we don't know enough to know what that means to everybody. I think it means something different to everyone, which is going to make it hard to write code for that one. And then compliance is kind of the holy grail. We would love for that to be a matter of configuration. We think that's probably where people will be rich, if anybody gets rich. Welcome to open source. Jason mentioned the working groups. The technology working group is the kind of the main space that we have a conversation with everyone every month. We have a phone call, talk about nerdy things, and try and provide a safe place for feedback and iteration. We do a lot of email, but the bandwidth that we have on the calls is quite high. So we encourage you to participate. If you're not receiving emails and you're interested in that, just let us know. It's very easy. It works very well. The metadata templates working group is what came out of the meta links, like Jason said. It really is about standardizing a process for what metadata looks like when it gets annotated. So it's metadata almost, right? But in a way that is descriptive via JSON or something else. And so this is quite complicated very quickly because everybody has an opinion and they're not all the same. We've got 4 major players in the room right now. They have each implemented something, and then once they saw each other's implementation, they realized, well, there's some overlap, but we had different opinions. So we've done this for about a year and a half now, and I think we're coming up on some agreement. I think the Venn diagram is tightening. And then so once we work that out a bit more, we will actually begin publishing a standard, if that's the thing that you can call it, if you just make it up. Everybody has standards, they just make them up. That's how it works. Everybody has a standard. So we're going to make one up, and hopefully we believe that we're kind of at the forefront of how to do this in an open way. There are a few other commercial entities and pieces of software that do this, but they only solve it for their business cases, and we don't necessarily know how much overlap there is. It would be interesting to have one of them, 2 of them show up once we publish this and see if we can get them to do the same thing. Then a lot more stuff becomes interactive, interoperable, and compatible. The future, one that we don't have yet, but we've talked about it for a few months, and we've had face-to-face conversations at Supercomputing, at Great Plains Network, ISC, about standardizing a log format. This one actually seems pretty straightforward. Of course, we haven't started it yet. Maybe it's actually complicated, and we just don't know enough. But can we just agree on what a change log looks like coming out of a parallel file system? There's not that many of them, and they have an incentive to play together as far as I can tell. We'll see how it works. But we've talked to, I think, 4 of the 5 on this list, all 5 on the list, and they didn't immediately just run screaming. So we'll see how that works. I'm going to bring these 3 characters up here. So Cory is going to talk about the new libraries that we have been working on in the consortium to make our own work better. Alan King is going to talk about the RE server, the rule execution server, and how it is not going to be called that anymore because that's confusing. As well as our work on intermediate replicas, which is a thing that didn't exist until a few weeks ago, and now is it merged? It's not merged. Intermediate replicas isn't merged. No, it's not real yet. It's going to be real. It's going to be great. And then Jaspreet is going to talk about our build and test infrastructure. And I'm going to watch the clock.
Hey everybody. So I'm Cory. I'm one of the core software developers for iRODS. And this year we have quite a bit of libraries to talk about and introduce you to. In fact, there's 6 of them. So the main goal of these libraries is basically that we want to provide standardized interfaces that make common tasks very easy. So things that you normally see in iRODS are things like iterating through collections or manipulating data objects, and so we really wanted to make that simple and for developers who use C++ because that's primarily what iRODS is written. And so going through these libraries, the first one is the query iterator, and this is kind of like the one that started it all. This basically it takes the jQuery C API and it provides a very simple interface that allows you to instantiate an object, you pass it your query, and you are able to iterate through the results very easily. So instead of you having to write maybe 50 lines of code, you get to write maybe 3 lines of code. And this is very beneficial because now you can focus on what you want your code to do instead of you having to worry about error handling and all these things. So our next one is the thread pool. This is simply, it's exactly what the name says. It basically allows you to quickly instantiate a pool of threads, and you can schedule tasks within those on that thread pool to do various things. Our next one is connection pool. It's built on top of the thread pool and allows you to quickly stand up connections within iRODS. So if you're doing things that require you to create and tear down connections, this particular API would benefit you greatly. And so our next one is the iRODS file system, and this is a pretty interesting one because it basically makes tons of things easier in iRODS, especially if you're writing client-side software. So this one came about because basically Jason would always, he'd walk around the room and say it would be great to have iRODS file system, and so I guess I just kind of set out to, as a side project, to see if it could even be done. And it turns out it can because iRODS basically implements the POSIX, it follows the POSIX standard very closely. So it was pretty simple to get it done. All the tools were there, and now we have it. So, yeah. Next one is the iRODS IO streams. And this is I think people will be very interested in hearing about this one because this is the one that pretty much implements basically you can read and write data objects using using a new class called dstream. And what we've done is taken it a bit further in that now we've externalized the transport layer. So now you get you can implement your own protocols to push bytes across the network. So to prove that this works, we've implemented a simple UDT server that shows that we can open up a stream and we can push data across the UDT protocol, and all these data objects appear within iRODS. This also opens us up to supporting things like RDMA in the future, which is very exciting. And so one of the things that the reason why this library is interesting is because we were able to, at an earlier TriRODS, we were able to implement a new IPUT prototype to see how the performance would do. And it turns out that it was massively easier to write a new IPUT application, and it turned out to be a lot faster with the help of the thread pool and connection pool. Our last new API is the query processor, and this basically encapsulates the new iRODS query iterator and allows you to basically say, you give it a functor, so basically a handler. So you say, here's my query, and here's what I want you to do with the results that you get after running this query. That makes it a little bit simpler since it's so common to do that type of thing. It makes it really simple to accomplish a lot of things. So all of these classes can be used on client and server side. By using these, developers can accomplish more with less code. This also introduces fewer bugs because now we've encapsulated all of the error handling, and we provide exception handling instead of you having to worry about error codes and things. So that makes it a lot simpler and lets you focus on what it is that you want to do instead of are we handling all the errors that could come out of this. This also makes fixing bugs faster. So for us, we're actually using these libraries in iRODS already, and we're seeing many benefits in using these. So all of these were originally planned for 4.3, but because they worked out so well, we backported them to 4.2. So yeah, I guess that's pretty much it.
I think Alan's next, right? So the last line there is important because those have already been released. So this stuff is already available in the development libraries. You can use this now just like us. 426 is already shipped 22 days ago. Yes, sir. Oh, wait, we got to throw in the box. Throw in the box. Don't hit anybody. All right.
Who needs the box? Oh, John Constable. I'm not going to throw it.
Thank you.
So about the thread pool and connection pool, some of our developers write the Baton software, and they'd be quite interested in using this directly from the API. So is it available from the API? Is there documented kind of code snippets about how to kind of use this and some kind of best practices kind of thing?
Yes, we have, I'm actually putting together a set of examples on how to use these APIs so that people can quickly reference these. We hope that people will actually try them out during the hackathon, see how they work. But yeah, they are very simple, and we will have things for you to look at to see how to use them.
And do you have any benchmarking about how it improves things, particularly with regards to small files?
Yes, so the IPUT prototype that I mentioned earlier, it actually it demonstrated how we could push large amounts of files, small files or large files across the network, and it turned out to be, I want to say at least, it was exponentially faster. So the more files you pushed, it would become faster, a lot faster compared to the original iPUT implementation. So I would say, yeah, it's much faster. It's much faster. I can't give you a number. I can pull up the slide, but it's yes. Yes, it was. Yes, the presentation that talked about that is available in the was it iRODS URL?
iRODS.org/iRODS. We have a quarterly meeting where we mostly talk to ourselves, but we might others. You record these, so they're on the web.
Thank you.
Do we have another question?
Hey.
Hey.
Wow, that's loud. So these libraries are very much embedded basically into when I want to do C++. Are there any plans in providing, I guess, stuff like the query iterator, query processor, or even maybe the IO stream, and exposing that as a first-class language independent API endpoint?
I imagine we do want to do that. If people want it, then we will definitely look into supporting that kind of thing. This is like basically the first step in basically making all developers' lives easier when it comes to writing iRODS software. So I don't see why we wouldn't try to do that.
Because the question is because right now we started out quite recently, I'd say, and finding actual APIs that I can use with any language, it's pretty hard, to be honest. Like there's a smorgasbord of libraries. Which one do I use? Is there any stable one? That's the questions we run into. So having that directly from you guys supported as a first-class member, that would be really, really great, because I can totally see how this stuff largely maps to something that I can externally use.
There's a Python query iterator also in the Python client. So we're starting to see a different implementation of the same work. It's proving useful, and so yes, it will happen. We only have one Cory right now, so we'll go faster. Any other questions before we give it to Alan? All right. All right, sir.
Hello, I'm Alan. I'm one of the core developers on the iRODS server. And I'm going to talk about some of the work we've been doing with the iRODS rule execution server this past year. Just to kind of explain how the old rule execution server worked, it was a fork exec model which synchronously distributes work on the delay queue, that is rules executed with the delay directive.
Click on this thing.
And it forked
Click on that tab.
It forked processes to make connections to iRODS, which would spawn agents and execute the work. There were a number of limitations that came along with this, and I know several of you in the audience have experienced these firsthand. There's a maximum of 256 rules per wake up that you can process due to limitations in how queries were iterated over. The long-running rules can actually block the entire RE server process, meaning if it takes a really long time for one of your delayed rules to run and it exceeds the execution window, that will actually block the server process from processing more rules. And if any rules are set to run later, they may be the only ones in the queue on a given wake-up, meaning they will block rules that are already ready to run. So we thought long and hard about it, and once we got some of our new libraries that Cory just talked about, found a good way to re-implement the server using these nice tools. So we rebuilt this in iRODS 4.2.5 using the query iterator, the thread pool, and the connection pool. What we did was we moved to a single producer multi-consumer model wherein the real execution server runs in a big loop querying for delayed rules, puts them on a queue that a thread pool is watching, and they just chew through the list asynchronously. The RE server goes back to sleep in the meantime, wakes back up, and looks for more rules to do, even if they are still processing the old set. So it's the querying for rules and execution have been separated so as to process them more quickly. So we use the query iterator to page over the results, meaning we can do more than 256 rules at a time. We limit the query by only pulling rules that are ready to execute at the time of the query. So rules set to run later no longer block those rules. And finally, they execute asynchronously using the in-memory queue and the thread pool, such that the RE server is no longer blocked by long-running rules. So I don't know if we ran any formal performance tests on this, but we were able to process tens of thousands of rules in a couple of minutes versus the 256, per wake up. So it's pretty good. And finally, for the future, looking towards 4.3.0, it turns out that calling something the iRODS RE server is ambiguous and confusing. So we are going to rename it to the iRODS delay server to reflect the fact that this is only a delayed execution server, executing delayed rules. We discovered, realized that the delay server is really just a big query processor, so we could probably re-implement it in like 3 lines of code. So we're going to try to do that, as well as allow for distributed delayed rule execution by default. So you can configure a list of servers to act as rule execution nodes in a way, and it can randomly it can dish out the rules by some decision to be determined. So that's what we've been doing with the RE server. Should we do questions?
Yeah, we can do questions on this. He's got one more slide.
Yeah.
If anybody has any questions about this particular piece. I think there are 2 or 3 people who have pain about this and they were in the room, but maybe we've already satiated them. It's much faster. Oh, it's John Constable again. All right. And why does he sit in the back?
Hi. So if the queue for the RE server is in memory, what happens if the server fails and is restarted? So, what happens to the items in the queue? Are they requeued? That kind of thing.
So once the rules have been successfully executed, they are removed from the catalog. If they are not successfully executed or the thread does not finish, it will not be removed from the catalog. So that is the persistence of the delayed rules. They stay in the catalog until they are removed by the executing thread.
And if they are found by the next wake up and they're still in the catalog, that queue is smart enough to not accept the same thing twice. So they don't double up, they don't stomp on each other, and they only go away when they're done.
Yeah, we compare against rule IDs in order to
That's
avoid
right.
collisions.
All right.
Next, I'm going to talk about another piece of iRODS we've been actively working on, and it's this concept of intermediate replicas. So what we have right now is this concept of there's newly created replicas, good replicas, and stale replicas. So what we realized is that we are missing a status in our replicas wherein the data object has been created, but the data is not yet at rest, and it hasn't been finalized in the catalog, so to speak. So what we did was we came up with the intermediate replica to represent the state of a replica registered in the ICAT database, but it has not, the data has not yet come to rest. If you're familiar with ILS, you know that an ampersand means a good replica. A space indicates a stale replica. We're now going to indicate intermediate replicas using a question mark, as it is unknown what state this thing is in. It's still moving. Along with this work, we are going to be attempting to address a number of issues that have come up. I can discuss with you later if you'd like to hear about those. But we would like to register all required replicas as per the voting in a resource hierarchy as intermediate before any data moves. So the catalog will have all of its needed replicas registered up front in the intermediate state. We will then call a finalize API of some sort for the immediate future, probably just close the data object to finalize it in order to complete the data transfer. So you'll notice in this output here, if you start putting a data object into a replication hierarchy, we have all of our replicas up front, all indicated by question marks. Once a data transfer has completed and it's finalized, it receives an ampersand and the size of the data object is registered in the catalog. The other replicas need to be, the data movement for the other replicas then begins as it does today, but they are still in the intermediate state as the data is still moving. Once the data has finished moving and all is at rest, you end up with 3 good replicas in the end. As a bonus, we also decided that showing a space for a stale replica is not particularly helpful or easy to parse if you're parsing through output. So we have decided to start using an X to indicate stale replica. Yeah, so that's the work we're going to be doing there. I haven't really covered all the various issues that this fixes just for the sake of time, but feel free to ask questions now or see me after and we can talk about it. So if there are any questions, yep.
Oh, John Constable? No. Who is it?
Right next door.
Oh, right beside him. Oh, God. Is this John's question? This is John's question, isn't it?
So we often have users who upload files and say, oh, I don't want to do that anymore, and press Control-C as the file's uploading. So how will that show up in this situation?
Right. So the idea is that you should never see an intermediate replica once the client returns. So you're either going to end up with a good replica or a stale replica. In that case, it will be a stale replica because the data did not finish transferring. If you do see an intermediate replica and there's no data moving, something has gone horribly wrong. Otherwise, you can assume that the data is still in motion getting transferred.
Yeah, that's going to be the stated position. If you find a bug, then you find a bug. All right, here it comes.
Thank you. Two questions. One is, will this apply to any existing code? If are the client libraries, or do we need to adapt any of application code for this? And the second one is, what if network transfers falters, and so you got, like with IPUT, you want to restart a transfer. Before doing that, what is the status of that replica? Is that also in the intermediate state then, or what does that look like?
Right. So the idea, to the first question, we are planning on bringing this to 4.2.7 or some 4.2 release. The only real difference is going to be the need to call the upcoming finalize API. You'll be able to accomplish this by closing the data object as you do today. The major difference with this new finalize piece is that you can call it repeatedly in order to update the catalog. With close, you have to have written bytes in order to update the catalog. And we've found that if that fails, then you're stuck and you have to restart the entire transfer. So that, I guess, would be the major difference from a client perspective. And to the second question, in the event of a network falter, again, the finalize call is what will ultimately determine the status of the replica. So whenever the replica fails to transfer, or if it succeeds, or the user cancels the transfer themselves on the client side, the finalize call will be handling the updating of the status. I don't know if that answers the question or not.
Yeah. So actually, if you would query the ICAT, you will be able to see the intermediate, if you like. So and the IPUT command, if you put it in restart mode, it won't be finalized until the restart has completed the full transfer of the file. Say I transfer like 2 terabytes and it fails, it breaks down after 1, then I can restart the IPUT, continue with the 2nd terabyte at that point, and then IPUT will finalize at the end. Is that correct?
That's correct.
Wonderful. Thank you.
Yep.
All right, coming around the back. All right, and then after this, we'll let Jaspreet do her slides. Make sure we finish.
Hi. Is there a jQuery column that also has this state in it?
I'm sorry, can you say one more
Is there a
time?
jQuery column that also has this state?
Yes, so the way replica status works is it is one of the columns for a replica, and it can, today, it's either going to be 0 or 1 for stale or newly created, or good, which is part of why we're doing this, because there's no way to separate the two right now. We are introducing a number 2 to represent the intermediate status.
So no new columns. We're just going from 2 states to 3. All right. Thank you.
Thank you.
All right, Jaspreet's going to come up here. I can drive. I can make it happen. Okay.
Hello, everybody. I am Jaspreet, and I actually am the gatekeeper of iRODS. I would consider myself as that. I'm changing my introduction this year. The reason why I call myself the gatekeeper of CI or iRODS is because if anything doesn't pass in CI or is not in CI, we just don't release it. That is why if you're wondering why isn't Ceph-Rados not released, it's because it's not in the CI. So I joined the iRODS team in 2017, and they had gone through 6 iterations of CI or 5 iterations of CI, and they had tried OpenStack, Node.js, Python, and in 2017 when I joined, they had like Jenkins, Python, Ansible, and something called zone bundles and vSphere VMs that they were using for their CI. So when I came in, I saw that they had all their code that was, the test code was, as well as the build code was in the Ansible land. So I decided that to make it more maintainable, we should create some test hooks and build hooks and put them in Git. So that would actually, like, if we were to Dockerize things or even make it more sustainable, it would be nice to have our hooks outside of Ansible. So that is what I did in 2017, and we still have that CI going on. Some of you did hear me make some promises. I think John was there last year in Durham, and he heard me make some promises, but most of you were probably not there, so I'm going to just repeat what promises were made last year. What I promised last year was I'm going to increase some coverage, basically add more plugins in CI. I did add a few plugins like the M-Time that Cory wrote, that was added. I don't remember anything else now, just that, I guess. And then I promised that I would move pipeline scripts to GitHub. Did that happen? We'll see. And I said I would address inconsistency. That meant, like, last year I had said that with our current CI we get some false reds because by Ansible hiccups, and we get false reds and we have to restart the test, and until and unless we don't get a green dot, we don't release anything. Did I fix that? We'll look at that later too. I had also promised that I would containerize Jenkins. Did I do that? We'll see. And possibly move VMs to containers. We'll see about that too. So in order to work on these promises, I actually did start doing something. We'll get to that in a while. So the reason why we haven't done anything is because of this, what you see behind, and actually my name has been changed to Jaspreet now. There's a story behind it. And because I do show them SAS whenever they come and ask me questions about why the CI is not working, because most of the time the internet has moved. And I have no control about that, and I cannot control when the internet moves and they change their SSLs and certificates. or they decide that CentOS 6 or Ubuntu 12 is not going to be supported. I can't do anything about that. And so the reason, so what happened, like I started looking at all those promises and I started working on making Jenkins public, because right now you cannot see what we are doing and what we are saying, is it really truth? So to make ourselves truthful, I have been working on making the CI public. That means containerizing Jenkins. And the people who were there last year know that we got hacked, so that is why we had to pull it off. So containerizing Jenkins would make it so that would make our lives easier, so that we can get all the security updates whenever they release something. So I'm going to move on. Should we? Yeah. Okay. So while I was doing this,
Can you talk about that? I'll bring up.
okay. While I was doing this, like you see that we Dockerized, I started working on Dockerizing Jenkins. And once I entered that rabbit hole, I decided let me just make everything Dockerized. So now what we have is one big job that when you push, it kind of builds almost everything, and it let me do this part.
It's being recorded.
Yeah.
A lot of dots.
Oh. Yes. This is it. No, he should have guessed it. Okay, I am just going to rebuild this and then go back to my sorry. I don't see. Oh, sorry. I'll move. Come on. Okay. I cannot find the rebuild
Okay.
button.
Here, talk about this real quick.
Okay. So basically, once I got into my rabbit hole of Dockerizing Jenkins, I started Dockerizing everything. I basically all the configuration is right now in Git. All the jobs and the pipelines are in Git. You can actually launch sibling Dockers, Docker containers. Like once you launch a job from the Jenkins, you have sibling Docker containers on your host machine. And you can build OS images, you can build iRODS packages, deploy and test, core, as well as plugins and topology and federation. So in a way, using Python, I have created a Docker compose file for your topology as well as a federation. I can show you that in a lightning talk or maybe sometime later if you are interested in what I have done to get this working so far. Development is same as production with this particular thing. And if you are interested in adding more things to this, you can always do a pull request and use this particular infrastructure. Like I know John has few things like tiers and batten he wants to put in the CI, so he can do it just using this now. Okay, so if my demo would have worked, what I would have done is, for the core, I would have been running 2 test suites. Basically, 4 containers would be running in parallel because I have 2 OSs. I have 2 plugins, one suite each, but since we have 2 OSs and 1 database, we'll have like 4 containers running in parallel. So and Federation has like 2 containers, but since we have 2 OSs, so we'll have like 4 containers in total running. So overall, like if you see that, like with one particular test, with this particular demo, you'd have like 20 containers running in parallel. And if we add like more databases, then you'd have, it increases the number of containers launched by 20. And since we have in our 4.2 stable, we have got like 3 OSs, 3 databases, and 31 test suites and 8 plugins, so you can guess like how big the explosion can be. So in order to minimize the explosion, because if we are going to use our own machines, I don't think so the developers can work because the containers take up a lot of space as well. But our test cycles are going to drop from 8 hours to, I would think, like the last time I tested, it was like 15 minutes. But the very first time it's going to take you some half an hour because it gets cached and stuff. So what's in the future, I will make iRODS public. And also investigate in scaling up. It could be Docker Swarm, Kerberos, who knows, whatever is easy. And this would allow us to increase coverage, like you guys can participate and add things, as well as with this Dockerized environment, you guys can add your own things and you'll have confidence, like and you can send us whatever. We can accept whatever you've tested on our test bed. So that's it. Thank you.
Thank you. No questions for Jaspreet. I got to go quick.
The demo will be done afterwards.
Yes. So I have like no minutes, and we will go fast. I guess I'm the timekeeper, so haha. So for 4.3, because all of our fancy stuff got ported to 4.2, that's great. So the only stuff left was the stuff that's hard and boring. So we're going to move the checksum technology down into the resource plugins. We can talk about that if that's interesting to you. There's a variety of reasons that's going to be helpful and powerful. Jaspreet said that the internet keeps moving, and that's true. So we need to update our use of external libraries so that we have the nicest stuff, as well as update our own schemas and make sure our consolidation of all those standards are up to date. We've moved some stuff since 4.2.0, which was 3 years ago, something like that. So we really haven't touched them because we're kind of scared of them. If we touch them, then we have to know everything about everything. And so we're only going to do that for 4.3. We've also had an overhaul of logging because our logging is not good, and now it's going to be better. Right now, it's great as long as your system is great. However, even then, it's inconsistently formatted. Sometimes it promises things that aren't true. It doesn't necessarily help you track things across multiple machines, and iRODS is only really terribly interesting once you have it in multiple places. So yes, if you've got iRODS in multiple places and something goes sideways, it's really hard to figure out from the logging what happened. So the goal is to reduce the amount of code that we have in the core that does logging. Already there's a lot of it, which is part of the problem. And we want to use an external logging library written by people who've thought about logging for many years and have done it really well. We've selected SpeedyLog right now as the interface. It's going to be speaking to syslog. So this will enable administrators to more easily capture what's going on and get it out to logging infrastructure, again, not run by us, right? It will have a consistent formatting. Right now we've selected JSON, so we've structured logs are the way to go. in the sense that we can chop them, process them with, again, external standardized tools. It allows us to track errors across multiple servers because we're going to bake into every log message who done it, when it happened, what they were trying to do, all that kind of stuff. It will allow you to tie into your existing infrastructure and provide a lot more options for output. This means that you may have seen a conversation on the chat list a couple months ago. So after all of that conversation and discussion and input, we have a little set of boxes here. The default system will still be a packaged system that writes to local files, but via our syslog. If you want to do something else and go to a different box, that's on you. It will be supported and it will behave. Non-package install, you can not really use our syslog because the whole point of a non-package install is you can't run things as root. So instead, we're going to be able to pipe directly out to standard out, and then you can catch it and send it wherever you want. It's also more friendly for Dockerized environments. So all of that said, we think we've got it nailed. We just have to put a bow on it and get it out the door. Big picture here at the end, we are moving towards policy composition. Yesterday there was a track on policy for the first time. I don't know what was said in there. Jason sounds really smart. I'm hoping it was good. The idea is that the story that we're now telling is not about the components, it's not about the technology, it's about policy. So this is the kind of end goal for many years. With these new libraries, we can do this, I think, pretty well. Our internals are going to drop dramatically in size. Bugs will go away. The interface remains the same. This is what allowed us to put it in 4.2 without changing things. You don't need to know all of that, but externally, it's a great story, and it means that we can now build smaller boxes that can be composed conceptually, metaphorically, right? Like we can now build tooling out of little pieces of software that actually work and don't step on each other's toes. It also means that you don't have to have those monolithic PEPs where you handle all possible cases in the post-proc for put, right? All possible things has to happen in this one giant function, no longer. So we've introduced this concept of continuation in the rule engine plugin framework. You can have one thing that does something and then gets out of the way and lets another friend of the same name do some work as well. You can compose these things together and stitch the policy you need. This is a big deal and we think really elegant. For 4.3, we're not going to change much except the logging and make sure that all of our stuff is good in terms of schemas. 5, we keep hunting because we keep backporting everything, so we don't know what 5 looks like. We're going to continue working on GUIs. Getting stuff into iRODS is a primary goal and what brings new people into the room, either because they bought another company or because they're a new entrant into the community. So getting existing stuff into iRODS is still a major use case for us. File system integration has moved forward dramatically this year. We want to continue doing that. We've got a lot of interest in getting iRODS accessible via nice, boring interface to Windows machines, like, say, maybe that have microscopes attached to them. So CIFS RODS will be a sister software project to NFS RODS. I'm hoping with a lot of overlapping code. And the only thing that changes is that virtual file system implementation for whatever server we pick for CIFS. And then also the iRODS console, we talked about the IPUT Prototype. We're going to probably try and make the one true iRODS command that will not be necessarily a replacement for all the I commands, but it will sit alongside of it, and as it grows and uses the nice things, eventually maybe if it has all the functionality, we can just not talk about the I commands anymore. You don't need 50 binaries on your computer, you just need the iRODS console. We're going to continue to building out those policy components. We've got 5 of the 8, right? More code, only configuration. We want installation and management of iRODS to become about policy. This is the story, we're going to stick to it. We need to hear your input. Let us know what that means to you, and we'll make it happen. You can do that through the working groups, show up on the issues, send us pull requests, that's cool. Then you're writing the code. Have conversations, talk to us, join, tell your friends. If you're publishing works, put us in them. If you're citing things, cite us. Talk to your friends and neighbors, right? Send people to us. This is how it gets better, and we don't know the use cases we haven't heard. So that's the story. It's 6 minutes over. I'll take one question if you have something really interesting to ask. Also, I'll be here for how many days? 3 more days? 4 more days? We've got time. We're going to take a break. Thank you very much.